This is a demonstration video for the GeoSketch 3.0 beta release. I'm going to demonstrate the bundle adjustment function. We have an ortho image and 4 oblique images which were imported from Pictometry. We have approximate camera models for these oblique images. Bundle adjustment is the process of mathematically optimizing those camera models such that when we digitize points representing a feature in the images, or in each of the images, they will project to the same point in the modeling space. I'll turn off the ortho image using a keyboard shortcut. GeoSketch uses the concept of bundle adjustment primitives, which are basically groups in your SketchUp model. And you want to have bundle adjustment primitives that are distributed throughout the area that you're going to model. And these primitives can be as simple as some points on the ground, such as the slab, or just boxes that represent rectangular buildings or structures, or they could be as complex as these pitched roof buildings. It's basically up to the modeler how much they want to use in detail for their selection of control points. Now, as I mentioned, these each are a group. If I select that group and right-click, the GeoSketch context menu has functions that you can apply to bundle adjustment primitives. Since there's already one defined for this, I have the ability to edit it to import some bundle adjustment results, or I can delete that primitive, which is what I'll do in this case for the purpose of this demonstration. This was primitive J. Each primitive has a label associated with it, and you can key in any label that you want, but it's best to try to keep those short. So I'll delete that primitive. And now, because there's not a bundle adjustment primitive defined on that, I have the option in the context menu to make it one. So I'll go ahead and do that. I'll go ahead and give it the same letter. It was letter J. If I wanted to, I could change the name of that group. This is the SketchUp group, and I can edit that here. And it tells me that there's 26 vertices in that primitive. So I'll select OK. So when you select a bundle adjustment primitive, when you first start the bundle adjustment function, it will zoom in to that. And that's one of the benefits of using primitives, is that rather than having to cycle through these views and search around to find the features that you want to use as control points, you can just use the left and right arrows, and for the current primitive it will focus on that in the aux view. So I'll use the left and right arrow. So for this pitched roof house, I'm seeing it in one of the aux views, and as I use the left arrow, I'll see it the next aux view, the next aux view. And that's handy for as you're verifying your control points that you've selected. Now the up and down arrows will cycle through the various primitives. So this is primitive C. If I hit the up arrow to go to one of those simple box primitives, or I can go back, use the down arrow to go down to primitive G, and I can go to the various primitives. So now I need to get to the primitive that I just created, which is labeled J. So I could just select it, or I can use the arrow to cycle until I find that. There it is. Now this one doesn't have any control points selected, so you can see that it's off by the amount that those original images were off, the camera model. So when you have all of the vertices off by a certain amount, you can use the Shift option to move these red lines. These red lines represent the projection of the bundle adjustment primitive into this particular aux view. So I'll hold the Shift key and do a coarse adjustment to get them over to approximately the right location. In this case, I'm looking at the ridge line. And once I've done that, I can select individual edges to put them in their proper location, and I can select individual vertices in a manner similar to the texture face tool. But it's important to remember that this is the representation of a 3D primitive projected into the 2D aux view, and I'm basically going to be adjusting the camera model to cause these points to line up. So once I've adjusted my red lines, which represent that projection, the prompt tells me that I can use the Control or the Alt key to set the control points. Now there's a special set of points that I'll show you in a moment that are for the ground points that establish the geolocation, but for points such as this, we just hold down the Control key because they're normal control points. And we do the symbol that is drawn over the point gives us information about how many times this point has been selected. Since this is the first view that I've digitized these, it's a triangle. A triangle says that it's only been digitized in one view. A square indicates two views, and then for 3 or more views it's represented by an X. So the objective is to get an X so that you know that you've digitized it in at least 3 views. If you've only digitized it in one view, whenever the symbol is just a triangle, then it will not play a role in the bundle adjustment process because it's only been digitized in one view. And you can move these points after you've put the symbol on them. So now I've got 6 points digitized here, and I can see this corner here, so I'll select that one as well. And now I'll use the right arrow to go to the next aux view. And again, I use the shift key to do my coarse adjustment of all of those projection lines. Zoom in a little bit, and now I'll do individual adjustments to the vertices and the edges. I might move this one out of the way so that I can see where that corner is and that corner in the back. And in this case I can see the bottom of this shed, and I can set that point there. So I've got those points adjusted. I need to move the ridge line a little bit. It's about there. And so now hold down the control key and select these points, and I now get a square because I've defined the points on the edge of the roof in 2 images. And then down here at the bottom I get triangles because this is the first image. Oh, that one I did in the other image, so that was 2. So now I'll do the right arrow and move them in this image. Use the shift key. It's a little bit fuzzy in this image, and that's another benefit of these bundle adjustment primitives. You can see the edge in some cases better than you see corners, and if by moving one vertex which moves the 2 associated edges, you can come up with a fairly good approximation of where the point is. There's some kind of fence here, so I can't see the points on the ground, so I'll just hold down the control key and do these roof points. I've now gotten them in 3 views, and I'll use the right arrow one more time to go to the last view. This one's quite fuzzy, but I can still see them. Use the shift key to move it over. I might decide that I can really only see these front images, these front corners very well, so I'll select those. But I can see these images like this one down at the foot, but not that one. And I might want to use that ridge here and here. Now for a summary of the control points that you've selected so far, you can use the Ruby console and hit the control tab, and it gives you a summary of how many points that you've selected. And generally you want to pick about 20 to 30 points in each image. I've actually got quite a bit more here. I've got about an average of 60 points in the image. The more points that you select, the higher the accuracy, but it's not necessary to pick this many. So for each one of my 4 oblique images, it tells me for each primitive, and there's the primitive label, how many points I've selected. And if you ever see that there's only 1 point selected, that will not be useful. So I'll close that Ruby console, and now I'm ready to run the bundle adjustment. So I can zoom back out to see all my views, and the prompt tells me that in order to run the bundle adjustment I hit the tab key. Now remember that I hit the control tab key to get a summary of all my control points. If I just hit the tab key, that will run the bundle adjustment. So once I run the bundle adjustment, I can specify an output directory for that, and I could give it a more unique name for this, but I'll just take this default. It's a good idea to put, if you're going to run bundle adjustment multiple times, for example, if you bring in a new image and you add some control points for that new image and you want to run bundle adjustment again, it's good to have a number at the end of the name, and GeoSketch will automatically increment that number if an existing bundle adjustment result exists. So there's various types for a bundle adjustment. In this case, I've selected some nadir points that will be used to geolocate the image. Those points are selected with the Alt key rather than the Control key, and their symbol will be green. So in this case I just had 4 edges, and those control points were features such as manhole covers or corner of curbs on the ground that were used as control points, the special control points. And that's the type of bundle adjustment that you'll most often use when you have pictometry data. If you don't have a orthorectified nadir image, then you can use one of the other cases, in which case you would select a set of planar points to define the up direction, or points that define an up vector. But for this case, we're using nadir points. This tells us the directory that I'm going to be processing this in, and the output directory. So I select OK. And the bundle adjustment process is actually relatively fast, and it's already completed. And now we have the option to import those camera files. So we have the option of reading in all of them, or just read in a certain one. If we added a new image and just wanted to bundle adjust it, we could do that, and we could select which of the images that we want to read it in for here, but I'll take the default, which is to read in all of the camera files. Now once we've done that, now our camera files have been adjusted, our camera models, so that we get more accurate projection. And one of the other benefits of these bundle adjustment primitives is we have the ability to solve for 3D points. So when I built these bundle adjustment primitives basically from the nadir view, so I wasn't sure of the slope of this roof or the height of the roof. So if I select this primitive, which is a group, and I edit that group, now in this case it is a pitched roof primitive, so I also have the option. I originally did not texture the walls because I did not have the bundle adjusted cameras, so I'll change that option to say that I want to use geospecific texturing on the walls rather than geotypical texturing. I select OK. Now, because this is a bundle adjustment primitive, I can select the option to first of all read in the bundle adjustment results. So bundle adjustment primitive, I'll read in the import the bundle adjustment update, and I'll go to that bundle adjustment 1 that I just did, and I'll read in the point cloud, and it adjusted the slope of the roof so that you can see that the slope changed and the height of the building changed. It read in the 3D locations to basically take the 3D geometry of that bundle adjustment primitive and adjust it. So now also, because by virtue of the fact that this is a pitched roof primitive, I'll say that I only want to use the nadir image for the roof textures, and I'm going to use geospecific texturing for the walls. So because this is a pitched roof primitive, I'll edit that group and I'll select that, and I'll say that I want to update the retexture that pitched roof primitive, and basically it retextures that based on the bundle adjusted cameras. So you can see, for example, that on this wall that the edge of the roof matches the texture on the wall. And we do have a lot of obscured images, and in the video for the texture face tool we'll demonstrate how you can correct that, for example using a different face to texture these obscured walls. So that concludes the bundle adjustment demonstration video.